Hello, welcome to Chem 120 Problems on Display on Canvas. Be sure to check your Canvas. There's all kinds of helpful information there. And it's done by me, which means it's explained the same way that I explain it in class, which may or may not be helpful to you, but at least it's consistent. So let's look at this problem. It's a magnesium problem. We're going to determine the average molecular mass of magnesium, and here's the problem. Magnesium is 78.99% magnesium 24, which has a mass of 23.985042 AMU, and 10% magnesium 25 with a mass of 24.985837, and 11% magnesium 26 with a mass of 25.92593 AMU. Calculate the average atomic mass of magnesium. Now remember, when we're dealing with isotopes, the same number of protons define magnesium. The only thing that changes is the number of neutrons. The number of neutrons changes the mass. So what we're going to do is take the average mass of all the occurring isotopes and add them together. So let's start. The first thing you have to do is convert all the percentages to divide by 100 and convert them to a whole number. So it's 0.7899 for the first one, magnesium 24. Let's underline all our numbers so that we can write them correctly when we transpose them to our paper. All right? So we're going to take that, and then we're going to multiply that to give the portion that's related to magnesium 24. So that weight is 23.985042 AMU. All right? So that's our first representative. That's Mg24. Now the contribution to the entire molecular mass of Mg25 is the percentage divided by 100. In this case, 10%. So we'll move the decimal 2 places. 0.1000. Make sure you have all your decimal places. We don't truncate until the end of the problem. And then we're going to multiply that times the atomic mass of 25, which is 24.985. 24.98537. 837, excuse me. AMU. And then we have one more contribution, and that's from magnesium 26, and that's 11%. So notice we're adding all these together, and that atomic mass number is 25.92593. All right? So that's the magnesium 26. So we're going to take the percentage of each one divided by 100. That gives us the contribution for each portion of magnesium isotope. This number comes out to be 18.94. What we can tell about that is the largest contribution to the magnesium molecular mass is 18.94, so it would be magnesium 24. The next one is 2.4985, and the final one is 2.854. If we add those three together, we get 24.298 AMU, which we then round to 24.30 AMU because we're limited by the significant figures of the percentages of 4. So 4 significant figures. Thanks for paying attention.